Hello, everyone. We are going to take our notes for 6.3. So we've done 6.1. We had all those exponent rules. We're skipping 6.2. We may go back over that later, but that's really all just a bunch of square roots, cube root rules, which we don't really need for this section. So we're moving right along to 6.3. We're graphing these different exponential functions or exponential equations. If you're in your student journal, we're on page 180. So you can take a second, write down this vocab. Okay, exponential functions. Be careful with this. It's any function that has a variable as your exponent. So this is kind of a misconception. Sometimes people will think that like y is equal to x to the third power would be an exponential function, but it's not. Okay, the exponent has to be a variable. Okay, so that's not an exponential function. It would have to look more like this. Y is equal to 3 to the x power. The thing that you're plugging in, the different values that you're plugging in are going to be your exponent, not the base. Right? So let's look at a couple examples of these graphs. We've got a bunch of different kind of variations that they could be. What I don't want you guys to do is look at this and think you have to memorize like, oh, if it looks like this, the graph should look, point up. And if it does something else, the graph should point down. It's honestly just going to be easier for us every time to just plug in our numbers into a table. But I just want to give you maybe a couple examples of some of these different exponential functions. So let's start over here. Let's say for this kind of gray line over here. I shouldn't say line. It's not a linear function, right? It's curved. So we don't have a linear function anymore. So any thoughts about slope, any of that type of stuff, it's not going to apply here. It's a curve. It's not just one straight line. It's not one consistent just rate of change. So let's say over here we had y is equal to 2 times 3 to the x, or usually it'll look like that, 3 to the x power. Okay. The biggest mistake that I see people make is they decide that they want to multiply the 2 and the 3 and then they take that to the x power. Okay, notice that it's ab to the x. That's not a very good parentheses. It's not ab all to the x. No, it is a, I'll either write it like this. It's either a times b to the x or a times b to the x. So when we start plugging in numbers for x, you're going to want to take, okay, whatever that base is. Let's say I plugged in 1. I'm not going to do a whole graph here, but if I plug in 1, okay, I'm not multiplying the 2 and the 3 first and then taking it to the first power. I'm going to say, okay, 2 times 3 to the first power is 3. Then I multiply together to get 6. I realize now for this one it would have worked the same either way. You've got to think about the exponent first, then multiplying. Okay. This one where it kind of points down like this, we would see if that outside number, if that a was a negative. Right? Then these that start off, they're kind of pointing up and then they go down to this one point. Or they have a line where they kind of taper off to. All right. That we see when b is less than 1, or in between 0 and 1, I should say. Okay, when we get y, let's say I had 2 and then 1/3 to the x power. Okay, again, I'm not going to multiply the 2 and the 1/3 and then take it to the x power. Okay, if I plug in 2 for x, I'm going to say 2 times 1/3 squared. I'm going to square the 1/3. Okay, that's the same thing as saying 1 squared over 3 squared. Okay, which 1 squared is 1, 3 squared is 9, and then 2 times 1/9 is 2 over 9. So that y would be 2 over 9. Okay, just to give you some examples of what some of these equations can kind of look like. All right, so let's go into some examples. I'm not super concerned with looking at a table and you decide whether or not they're linear exponential. I'm more concerned with, can you take one of these exponential functions, can you plug in a number, figure it out? All right, so let's say we've got this 3 to the x power and then x is equal to 5. So y is equal to 3 to the x. Okay, I'm plugging in 5 for x. So y is equal to 3 to the 5th power. Okay, then I've got to type that into my calculator. Again, don't say, oh, 3 to the 5th power, that's 3 times 5. Okay, you're not multiplying them together. You're saying 3 to the 5th power. That's 3 times 3 times 3 times 3. That's 3 times itself 5 times. So I do have to put this one in my calculator because I don't know off the top of my head. Okay, 3 times 3 is 9, 27, 81, 243. Okay, 243. That's my y value. Okay, so if I was making a little x and y table and 5 was what I plugged in, I'd get 243 for my y. Right? All right, let's go on to the next one. Okay, I've got 1/4 to the x, and it wants me to plug in 3 for my x, for my exponent. Okay, so that means I'm taking the top and bottom of my fraction to the 3rd power. Okay, 1 to the 3rd power, 1 to any power really is just 1. And then 4 to the 3rd power, I believe, is 64. Where's my email again? All right, 1/64. That's my final answer there. I'm going to do 7 just because I want to do one of these with 2 numbers because I see people mess this up all the time. Okay, 3 times 4 to the x power. 3 times 4 to x is equal to 4, so to the 4th power. So this is what people always do. They say, oh, awesome, 3 times 4 is 12. I'm going to take that to the 4th power, but that's not what you do. You take 4 to the 4th power, then you multiply it by 3. You're going to get goofy numbers if you multiply them first, then do the exponent. You got to do that exponent first. Okay, 4 to the 3rd power is 64. So let's do 64 times 4. I get 256. Some of you are good at mental math. Some of you probably figured that out quicker than I did. 3 times 2, 56. Okay, I'm going to multiply that by 3. And I get 768. Okay, we can see that these numbers sometimes get extremely big, extremely fast. That's only for plugging in just a 4 for your x value. So don't get too frustrated when you try to graph some of these. Try to pick somewhat small numbers that you're using to plug in. You don't want to try and graph 512 or something on your XY plane. All right, so we're going to go over here and we're going to graph both of these problems, except I'm going to make a change. So if you're doing this in your student journal, make sure you change it on yours too. I think it's going to be better. Let's do 8. Let's change that to a positive. So let's change that to just 2 to the x power, not negative 2 to the x power. And let's have 9 be our negative. Okay, so let's have 9 be our f of x is equal to negative 2 times 1/4 to the x power. I just like that a little bit better. I think it's a little bit easier to get across what to do when you have an a and b value. I just think it's a little bit easier and I get to change things when I want to, so here we are. So again, don't get confused. Don't look at your paper and go, that's not the one that I have, right? Changing 8 to be a positive, we're changing 9 to be a negative. All right, so we want to make first of all, before we do anything else, before we make our little coordinate plane, anything like that, let's do a little X and Y table. Okay, we're going to come up with a bunch of numbers to plug in for X and then see what those values are for Y. It gave us these equations in function notation. So if that function notation is hard for you, if it doesn't make sense, just change it to an equation. Instead of f of x, just change it to y equals 2 to the x power. Don't let function notation throw you off, right? So first off, we want to make sure, let's use numbers that are close to 0, okay? Because the larger numbers, like the larger of absolute value a number has, the higher chance that it's going to be a number that's really hard to graph. If you take something to the 5th or 6th power, a lot of times it's going to be a super, super, super high number. So we want to stay right around 0. I like to pretty much always use -2, -1, 0, 1, 2. A lot of times those gives us easier numbers. If you wanted to take out maybe the -2, you could, but I would say at least 4 numbers when you're graphing these exponential equations. Otherwise, you're not going to really see what the pattern should look like. Okay, so one by one, we're just going to plug all these numbers in. It's not like a linear function where, oh, I found the slope, okay, up 2 over 1. It's not a straight line, so there's no kind of trick or shortcut or anything like that we can use for exponential. It's just plug in a bunch of numbers, put them on your graph. Okay, so let's do that. Let's start with -2. I'm going to use the, I didn't mean to erase it. I'm going to use the equation rather than the function because I think that might just be easier to look at. Okay, so y is equal to 2 to the x power. So let's figure out what y is when we take 2 to the -2 power. That's why we spent all that time last week going over those exponent rules, okay? Because we kind of have to know what those mean. Okay, 2 to the -2 power, well, anything to a negative power is just going to be that number taken to that exponent, but the reciprocal. Okay, 2 to the -2 power is the same as 1 over 2 to the 2nd power, 2 squared. Okay, I can simplify that. I know that 2 squared, 2 times 2, is 4. So that's the same as 1/4. Okay, so that's my y value and my x is -2. I'm just going to keep doing this and doing this for all these different values. Okay, so y equals 2 to the x. I'm going to do the same thing for -1. Okay, same thing. I can call that 2 to the 1st power if I really want to, but we know that 2 to the 1st power is the same thing as 2. We can simplify that down. Okay, so 1/2 there for -1. All right, let's do another. We've got 2 to the x. We have x is equal to 0. So 2 to the 0 power. Okay, hopefully you remember from last week, anything to the 0 power is 1. So 1 right here. Okay, the next two should be easy. Okay, I have 2 to x is 1, so 2 to the 1st power. Okay, anything to the 1st power is just itself. So 2. And then 2x is 2. So 2 squared we know is 4. 2 times 2 is 4. Okay. Now remember our exponent rules. I'm not doing 2 times 2 because it's 2 to the 2nd, so I'm doing 2 times itself. Okay, 2 times 1, 2. Right? I know that's confusing. Okay, let's not forget our exponent rules. Let's say I had something like 2 to the 3rd. Okay, that's not 2 times 3. It's 2 times 2 times 2 3 times. Okay, I just want to repeat that because a lot of times the first couple times we do exponents, people kind of get those two things mixed up. Okay, so 2 to the 3rd isn't 2 times 3. It's not 6. It's 2 times 2, which is 4, times 2, which is 8. All right. So I'm going to give myself, it's always hard to draw lines here, so I'm going to give myself a little line. I need to draw my X and Y axis. Okay, that's my Y. Don't really have any negative Y values, so I'm going to, that's my minus 1, 4. This should be fine. You kind of have to be a little bit creative with these. Sometimes you need more room on the top. Sometimes you need more on the bottom. Make sure you're giving yourself plenty of room. All right, make sure you definitely have graph paper. I have some that I can give you guys in class. I would not try and do this all on notebook paper. It's probably going to be pretty messy. Okay, so all of these values here in your table, those are just points that you can plug onto your graph. Okay, -2 and 1/4, that's a point. -1, 1/2. Okay, all of these are the points we're plugging into our graph. 1, 2, 2, 4. Those are my XY points. Okay, I'm going to do these in red just so it's a little easy to see. Okay, starting with kind of that harder point, 2 and 1/4. Okay, kind of over here. If you get a fraction or a decimal and you're trying to think, well, I don't know exactly where 1/4 is, just kind of guesstimate it. I'm not going to get out a ruler and say you're a millimeter off. Okay, just get it as close as you can. Okay, -1 and 1/2, that's about there. 0 and 1. Okay, we can see these are starting to rise now. 1 and 2. And then 2, 4, so 1, 2, 1, 2, 3, 4. Okay. We also kind of did 2 to the third, so I don't have to plug that in, but I could just for fun. So 3 and then 2, 3, 4, 5, 6, 7, 8, just to kind of give you an idea of what this general shape is going to look like. This is why it's nice to kind of have a lot of numbers. Okay, and then kind of connect them as smooth as you can. You can't really use a ruler since it's not a straight line. Okay, you're going to make that curve. Right? So each one of these does kind of take a long time. Again, there's no slope. There's no, oh, here's the y-intercept. You're not really making, there's no kind of tip or trick to make this super fast. You just have to make the chart, plug in your values, and kind of move on from there. Right? So I want to do number 9. Okay, if you feel like you've got it, you could always come up with the numbers on your own, fast forward, see if you get the same numbers I do. Okay, so let's look over here. Same deal. If the function notation stuff is confusing, I'm just going to change it. Now it's y is equal to -2 times 1/4 to the x. Okay, remember I added a negative for this one. Same deal. I want to have my x and my y values. I want same ones, -2, -1, 0, 1, 2. And I'm just going to go one by one. I'm going to plug all of these numbers in. Okay, so y is equal to -2 times 1/4. It's to the x power. I'm going to plug in -2 first. Okay, -2. Okay, so both of these values are going to be taken to the -2 power, which just means I should flip both of them. Okay, so that changes to 4 squared on top, 1 squared on the bottom, which 1 squared is just the same as 1. So I'm just have this over 1, so it doesn't really need to be a fraction, but 4 squared, again, not 4 times 2, it's 4 times 4, so that's going to be 16. Right? -2 times 16, I get -32. That one I may not be able to fit on my graph. That's okay. All right, I'm going to do the same deal, but just with my -1. So 1/4 to the -1. All right, same deal. I know that everything in here is being taken to the -1 power. No, this isn't the easiest math, especially since some of these exponent rules are new. So 1 to the -1, 4 to the -1. That just means we're really just swapping what side both of these are on. Now the 4 is on top and the 1's on the bottom. So really that's just 4. Now we've got -8. That's probably a number that we could graph. Okay, we've got this whole thing over here, -2 times 1/4. We're taking it to the 0 power. All right, and again, this is why it's super important. You're remembering it's not 0. Okay, anything to the 0 power is just 1. Okay, the whole answer isn't 1 though, because you're multiplying it by -2. So we get -2 here for this y. And then we're going to plug in 1 and 2. Those should be fairly simple. -2 times 1/4. This is getting taken to the first power. That really doesn't change anything. Anything to the first power is just itself. So 1/4 to the first power is just 1/4. Okay, if I want to multiply these two fractions, I could write it out like this. -2/1 times 1/4. Okay, -2 times 1, so -2/4, which simplifies to -1/2. Okay, get that in for my y. Same deal, I'm going to erase this over here, that to the third. Give myself some room. All right, so y is equal to, I'm going to have -2. Okay, 1/4, this is all squared. Okay, so I'm squaring both of these. I'm squaring the 1. I'm squaring the 4. All right, so -2. So 1 squared is just 1. 4 squared is 16. I don't know why I wrote 12. 16. And then again, I can multiply my two fractions. Okay, -2/1 times 1/16. All right, I'm going to get -2/16. That's -1/8. Right? So I have -1/8. So I'm going to start plugging these in. I need to decide where my, I'm going to draw my x and y axis. I have a lot of negative numbers here, so this is going to look a little bit different than the one I just drew. I'm going to give myself plenty of space with these negative y values. Okay, so I'm going to have my x-axis right here. Don't have any positive y values, so I'm going to draw it here. That's pretty ugly. I'm going to try that again. And then y-axis can just kind of go right down the middle. Doesn't really matter. Probably shouldn't make it crooked though. Promise this is easier to do on paper than it is to get done on my laptop. Oh, that was the eraser. Oh, I am struggling. Okay, there's my line. There's the other one. Good enough. All right. Now I can draw all these different ordered pairs. All right. If it's confusing to look at in the chart, just bring them all out of the chart. Okay, -2, -32. I'm not going to fit that one on my graph, but I could do the next one. -1 and -8. 0, -2, 1, -1/2, 2, -1/8. The rest can all fit on my graph. Okay, so -1, -8. 1, 2, 3, 4, 5, 6, 7, 8. It's going to go right there. 0, -2. And then 1, -1/2. Again, you can kind of guesstimate for the fractions. And then 2, -1/8. Right? So we can see how these connect. Then you're not going to cross that x-axis. It's going to get close up to the x-axis. It's going to keep going, but it's not going to cross. Okay, and we kind of see the shape of these. I know each one of these takes a little while. It's all right. I'm not going to give you a ton for homework. Just practice a couple and we'll be in good shape. And I'll see you guys later.